All right, today we're diving into a conflict that is, no exaggeration, shaping our century. We're talking about the massive tech war between the US and China. But forget about armies and tanks. This is a battle fought with algorithms and microchips. It's a fight for who will control the future of artificial intelligence. And really, this whole thing boils down to one single massive question for China. Seriously, think about it. How do you build the future when your biggest competitor has all the best tools? It's like you're trying to build a skyscraper with a handsaw while they've got state-of-the-art power tools. That's the corner China's been backed into, and their response, well, it's forcing them to get really, really inventive. So, to really get what China's trying to do, we first have to understand the wall they're running up against. Let's break down America's chip embargo and, why it happened in the first place. Okay, so the United States watched China's AI capabilities grow at an incredible pace and decided essentially to pull the emergency brake. They rolled out this sweeping embargo that blocked China from getting the world's most advanced semiconductors and, this is key, the super specialized tools you need to make them. The goal was pretty blunt: slow down China's AI ambitions by cutting off the supply of the most important ingredient. Now, the one piece of technology at the heart of all of this is something called lithography. The easiest way to think about it is like a microscopic printing press for computer chips. The whole game, the absolute goal, is to print smaller and more complicated circuits onto silicon. The smaller you can print, the more powerful and the more efficient your chip becomes. In this slide, wow, it just perfectly illustrates the technology gap we're talking about. China has access to the older tech, deep ultraviolet, or DUV. The source material uses a great analogy. It's like trying to draw a detailed circuit with a thick crayon. The cutting-edge stuff is extreme ultraviolet, EUV, and that's like drawing with an ultra-fine point pen. You can just imagine how much more detail and complexity you can cram in. And here is the absolute crux of the issue. There is only one company on the entire planet that can build these game-changing EUV machines. It's a Dutch company called ASML. And with a lot of pressure from the US, they are banned from selling these machines to China. This isn't a soft barrier. It's a hard physical limit on China's ability to make the best chips in the world, period. So the front door to advanced chip making gets slammed shut. What do? Well, you've got to find a side entrance, right? And this is where the story pivots from being about restriction to being about pure invention. All right, let's meet the contenders on the hardware front. In one corner, you have America's NVIDIA, whose chips, like the A100, are basically the undisputed heavyweight champions for training AI. And in the other corner, you have Huawei's Ascend chip. It's China's best shot, their top domestic alternative. But as you're about to see, they are definitely not in the same weight class. And yeah, the performance gap it's a big one. NVIDIA's A100 chip is just way more powerful. To put some real numbers on it, you've got the A100 delivering around 2,500 teraflops of computing power. Huawei's best chip? It's closer to 800. That is a massive hardware disadvantage that China has to try and overcome with software. Which brings us right back to that central problem. If your individual processors are just fundamentally weaker, how on earth do you build an AI system that can go toe-to-toe with the best in the world? Well, you have to stop trying to win with brute force and start getting really, really creative. And this is where things get so interesting. This is the heart of China's countermove. They figured if they can't win on hardware muscle, they have to try and outsmart the problem with software and clever design. It's a perfect example of that old saying, necessity is the mother of invention. So how does this actually work? Well, take Huawei's CloudNet system. They literally link thousands of their weaker Ascend chips together in a massive cluster. But the secret sauce, the real magic, is in the software. It is incredibly sophisticated at shuffling data between all those chips so efficiently that the whole thing starts to act like one giant distributed brain. They're also innovating on a much deeper level. Chinese engineers are basically inventing new ways for AI to do math. This method, a fractional component number, is a great example. Think of it like this. For some problems, you don't need a super long, precise decimal. A simple fraction works just fine. It's a simpler way to represent numbers, which means it takes less computing power and less electricity to get the job done. It makes their existing hardware go a lot further. But, and this is a really big but, these clever workarounds can only get you so far. As impressive as China's ingenuity is, they are still facing some very real and very hard limits. This whole strategy runs into three major choke points. First, that EUV machine problem. It's not going away. It's a physical wall you can't just innovate your way around. Second, they're still really dependent on American software to actually design their chips. And third, their main workaround, clustering thousands of weaker chips, is an energy hog. It uses about 4 times more power to do the same work as a top-tier NVIDIA system. And all these limitations, they lead to a much bigger question about strategy. The source material points to this fascinating and kind of cautionary historical parallel. Mao's Four Pests campaign back in the 50s. It was this massive top-down government plan that had absolutely disastrous, unforeseen consequences. It really makes you wonder, can a huge state-directed push for innovation ultimately win against a more flexible, market-driven approach in the long run? So what does all of this mean for the rest of us, for the world? Because this fight over tiny pieces of silicon is actively shaping the future of artificial intelligence for every single one of us. And here's why it matters so much. This isn't just a trade spat. The winner of this race doesn't just get richer. They get to write the rule book. They set the standards for the AI that is going to be woven into every part of our lives, from our healthcare and our cars to how we even get basic information. And that leaves us with this final, massive question. Is all this pressure actually forcing the creation of a totally separate, parallel Chinese tech universe? Could we be walking into a future with 2 different internets, 2 different AIs, and 2 completely different technological paths? It's a pretty wild thought, and the answer is being written right now, one microchip at a time.